In terms of the first design example, we're going to look at the half-lap connections for panel-to-panel connection design, and in this case, we're going to take the 180 millimeter CLT from Sodra. We have some diaphragm reaction forces that we design in our CLT diaphragm, and these are practically the results of that. We have some inputs in terms of which half-lap we're going to use and which screws we're going to use. So we have the app that Adam already showed you a bit in the beginning. So what is interesting about the screws and connection itself, so you can filter out what category you want to use. In the case of the screw connection, when you select screws, you're going to see only screw suppliers available here and connections where these screws are available. So you can filter either by specific supplier or by category, but here is the list, which is also something that we're going to extend also in terms of the available suppliers, and we're always working on improving and adding more connections to our platform. So in terms of specific connections, so we have a specific connection detail where you can address some typical connections, but the most powerful and recent updates is based on the screw design, which I'll both take you in our example. So firstly, we're going to talk about the CLT floor-to-floor half-lap connection design, and that's something I already pre-configured here, so we have more time on pointing out what are the main functionalities and features. So here I already pre-selected the Eurocode design. We have Sodra selected as a supplier, but you have the full flexibility and interoperability between the suppliers. So no matter what connection you're designing, you have the flexibility to change and pick up what is the appropriate grade and properties of each CLT supplier together with the same applications for the screws. In this case, we selected Sodra and we selected 5 layers, 180 millimeters layup. We have with set of 200 millimeters, but that's something that we can easily change. On the right side of the app, we have option for seeing dynamically what's happening. So you have option with 3 views on the 2D section. So basically, what's happening in sections A and B, and on the top view. And here we have some configuration in terms of how we're calculating the connection. So in this case, it's selected on the continuous or per meter, but you can also, if you want to have some exact length of connection and not just to verify connection, but to get what is the exact number of screw, you can go with discrete type. Going further, we have here option for selection of suppliers, so full flexibility in terms of supplier available for selection. In this case, I pre-selected Eurotech screws, and when a supplier selected, you have full availability of their screw data. So in this case, I pre-selected panel twist deck, partially threaded washer head screw, so something that is being used for this kind of connection. And once the screw family is selected, you have ability for select exact diameter and length. So this is something that where you can select the exact type of screw you're going to use. Going further, we have also option for different analytical methods. So as some of suppliers have specific calculations regarding the rope effect, have differences in how the application of these screws works in mass timber. So what are the intermediate edge distances? Something that is important to have as an option is also going with the ETA from a specific supplier. Choosing that might not be affecting the overall capacity of the connection. So if we see what is the result of this connection with the ETA, and we'll switch back to Eurocode, we're going to see that the difference is around 7% in this case. So there are not going to be a significant differences between that. But the good point is, in some specific application, geometry check will help you to assist and get you more precise information when things are not maybe addressed by Eurocode, or when you have some specific screws with already pre-drilling tips. So pre-drilling is practically no needed. So that's something that ETAs can be very helpful. In terms of the screw geometry, so here we have option with the positioning of the screw and spacing, applying the specific loads. So already entered the values that we have in our design example. And the last part is regarding the design parameters for Eurocode. So gammas, what is the load duration, series classes, and are we using pre-drilling or not? In terms of the summary and report, so this is something that is in specific for this calculator, but it's also scaled up to all of our platform, is that we try to be fully transparent and provide all the information regarding the results. So we try to call ourselves, we're not a black box. So we have the geometry check and share capacity here with some specific nodes, but if we go into the details, you can see what's happening in details regarding the positioning, and also in lateral capacity, we have here a calculation of rope effect at the beginning. And then we have, if we go down, we have also all the failure modes listed here. So all 6 failure modes according to European yield model. We have the summary of all the failure modes, what is the lowest capacity, effective number of screws, and shear capacity of the connection. So I'm gonna just try to get through this quickly, so I can also show you the other connection details, but just to show you a preview of how this works. On the right side, we also have ability of seeing what's happening at all time in terms of the imagery and positioning of screws, and also how we change the results, that will also affect the design.